our group assignment for subject Linear Algebra and also known as MAT263. Our team consists of 4 members. The first person is Nik Zafira Aisyah binti Zahari. The second person is Nur Amila binti Mat Saufi. The third person is Yasmin Hani binti Zainul Hasrin. And me, the last person is Nur Farahani binti Roslan. For your information, our group get the task to do the case study about anything that related to linear algebra. Also, we need to choose one of the topic that we learned in the class and related in our life situation. So, we are choosing a Gaussian elimination method for applying in proportion of ingredients used to make desserts for our bakery.
Elementary row operation are basic manipulation on the rows of a matrix used to simplify it. This operation includes swapping rows, multiplying a row by a non-zero number, and adding or subtracting a multiple of one row to another. They help solve system of linear equations and find properties like the matrix rank and inverse. Elementary row operation divide into 2 methods, which is Gaussian elimination method and Gauss-Jordan elimination method. But today we just focus on Gaussian elimination method. Gaussian elimination uses this row operation to transform a matrix into a simpler form. The goal is to make all entries below the main diagonal zeros and then make each leading one with zeros in its column. This makes it easy to solve the equations and understand the matrix structure.
So, we move on to introduction of the case study. As we can see, Shalani Bakery produce 3 types of baked goods, which are croissants, apple pies, and muffins. Each product requires a specific amount of flour, sugar, butter, and eggs. The bakery has daily constraints on these resources, which are given below. Daily resources limits for flour is 201 kg, for sugar is 144 kg, for butter is 96 packets, and for eggs is 192 eggs. Croissants requires 21 cups of flour, 15 cups of sugar, 3 cups of butter, and 6 eggs. Apple pies requires 9 cups of flour, 6 cups of sugar, 6 cups of butter, and 12 eggs. Muffin requires 12 cups of flour, 9 cups of sugar, 9 cups of butter, and 18 eggs. So, what is the problem statement? The problem statement is the bakery wants to determine how many units of each product for croissants, apple pies, and muffins can be produced daily without exceeding the resources constraints. So, how much we can produce these desserts?
I'm going to talk about purpose of study in our group project. The purpose is to determine the quantity of each product, croissants, apple pie, and muffins. Next is to discover the better way on how to apply matrices based on real-life problems. The third is to calculate how much the bakery can produce of each product by using matrix method, which is Gaussian elimination method.
My name is Nik Zafira Aisyah binti Zahari and I'm the next person to present. We move to methodology. First step, we should assume the croissants, apple pies, and muffin as A, B, and C. Second step, we have to produce linear equations from the problem statement. And the third step is change the equation into an augmented matrix form. For row 1, we got 21, 9, 12, and 201. For row 2, we got 15, 6, 9, and 144. Third row are 3, 6, 9, and 96. And the last row are 6, 12, 18, and 192.
To solve the given system of linear equation using Gaussian elimination method, we first represent the system as an augmented matrix. Initially, we scale the first row by dividing each element by 21 to simplify the numbers. Then, we eliminate the entries below the leading one in the first column. Specifically, we subtract 50 times the first row from the second row, 3 times the first row from the third row, and 6 times the first row from the fourth row, resulting in zeros in the first column from these rows. Next, we simplify the second row by scaling it by -7/3, turning its leading one. To eliminate the second column's entries in the other row, we subtract 66/7 times the second row from the first row. Afterwards, we scale the third row by 1/12 to make its leading coefficients 1 and eliminate the third column entry in the fourth row by subtracting 24 times the third row from the fourth row, resulting in a row of zeros. At this point, the matrix is in row echelon form and we use back substitutions to find the values of A, B, and C. Starting from the bottom row, we determine that C equal to 6 into the second row, we find B equal to 5. Finally, substituting B equal to 5 and C equal to 6 into the first row, we solve for A equal to 4. Thus, the solution to the system of equation is A equal to 4, B equal to 5, and C equal to 6.
So, how much of each kind of dessert can be produced by using constant ratio of ingredients? From our way of solving this question by using Gaussian elimination method, the result we can produce 4 pieces of croissant, 5 pieces of pineapple, and 6 pieces of muffin. From our discussion, using this Gaussian elimination method, we may determine the number of croissant, pineapple, and muffin can be produced based on this discussion, with a ratio of ingredients including 201 kg of flour, 144 kg of sugar, 96 packets of butter, and 192 of eggs. Proof that using this method, we can estimate how much ingredients can be made for every type of dessert at our bakery.
Conclusion: the Gaussian elimination method proves to be an invaluable tool for solving linear equations, especially when dealing with systems that have more than 2 unknowns. By systematically transforming a complex matrix into an upper triangular form, we can efficiently derive solutions that might otherwise seem daunting. This method not only simplifies the process but also ensures accuracy and consistency in finding solutions, making it a fundamental technique in mathematics and various applied fields. Beyond theoretical applications, Gaussian's elimination's versatility extends to everyday life, including tasks as simple as making desserts. For instance, when managing multiple recipes that share common ingredients, setting up a system of equations can help determine the exact amounts needed, optimizing resources, and minimizing waste. This method enhances our problem-solving abilities, making it a practical and powerful tool in both academic and real-world scenarios.
These references are essential sources we are utilizing to guide and inform our conduct of this case study. Thank you for taking the time to listen to our presentation. We sincerely appreciate your attention and hope that you found our message clear and enjoyable, especially in watching our video. We apologize if there were any mistakes. Your engagement means a lot to us. Thank you again. Assalamualaikum warahmatullahi wabarakatuh.